Hello, we are discussing about GATE 2014 ECE paper, and this question is related to digital circuits. A 16-bit triple carry adder is realized using 16 identical full adders as shown in the figure. The carry propagation delay of each full adder is 12 nanoseconds and the sum propagation delay of each full adder is 15 nanoseconds. The worst case delay of this 16-bit adder will be. What is the worst case delay of this 16-bit adder? That is nothing but what can be the maximum amount of what is the maximum amount of time you should wait to get the final result. Okay, this is a ripple carry adder. For that one we are going to calculate how much time it requires to get the final output, that is after application of inputs how much time does it need to get the final value. Okay, and what was given is nothing but propagation delay time for the carry is 12 nanoseconds. Propagation delay for the sum is given as 15 nanoseconds. So it was given that one propagation delay time for the carry is 12 nanoseconds and propagation delay for the sum is 15 nanoseconds. So what you must remember is nothing but full adder is a combinational circuit. What is the characteristic of combinational circuit? Combinational circuit output depends on the inputs only at that instant of time. Whatever the inputs present at that instant of time, based on those values, output will be determined. It doesn't require any previous values or it doesn't require any future values. So combinational circuit doesn't require any memory because of that one. So output is directly proportional to input presented that instant of time. For example, at t is equal to 0, you are applying the inputs. Inputs you are applying is nothing but all A0, B0, A1, B1, A2, B2. All these inputs are going to be readily available, which you have connected for the 16-bit full adder. Okay, and the outputs directly depend on the inputs present for this one. But if you are observing for FY1, for the first full adder, the input is nothing but C0. But C0 is not readily available. C0 has to be generated by the FA0 full adder. Okay. Similarly, full adder 2 that requires an input, that is C1. That C1 has to be generated from the FA1. FA1 requires C0 that internally generated to the FA0. So like this, FA15, this is last full adder. It requires a carry which is nothing but C14. Until and unless C14 is readily available, you cannot get the final sum and carry. Okay, your final sum will be available only whenever C14 is ready. Whenever C14, when will it be ready? C14 will be ready whenever A14, B14 and C13 is going to be ready. Okay, so that all the things is nothing but carry has to be readily available. Okay, so for this one, let us assume you are applying at t is equal to 0, inputs applied. So after 12 nanoseconds, this C0 is available. So after 12 nanoseconds, C0 is available, so that this C1 can be calculated based on this 12. So it requires another 12 nanoseconds. So it requires another 12 nanoseconds to get the C1. Okay, here we are not interested in the sum because we are interested in the carries, because carry C14 has to be available to get the final output. So like this, if you are going for the third one, it requires another 12 nanoseconds. Similarly, for this FA14, it requires another 12 nanoseconds. This also requires another 12, but this is the final. So C15, even though it is ready, but you must get the final, is nothing but S15. So this itself is going to be taking 15 nanoseconds by the time S15 is ready, and all are going to be readily available after 15 nanoseconds. Okay, so S0 is available after 12 nanoseconds, S1 is available after, this is 15 and it is taking 12. So 12 plus 12 is 24 and this is 15 plus 12 is nothing but 27. So after 27 nanoseconds, S1 is available. This is 24. 24 plus 12 is nothing but after 36 you will get the third. So similarly, the total propagation delay, worst case delay, is nothing but since it is 16 bit, 15 times of T carry requires plus 1 time of T sum it requires. That is nothing but for this is for the last full adder. Last full adder, whereas this is for the all n minus 1 full adders. N minus 1 full adders. So what we require is nothing but n minus 1 times of, okay, T carry, propagation delay of carry, plus 1 time of propagation delay of sum. So by that time n is 16 bit, 16 minus 1 is nothing but 15 into 12 plus 1 into 15. So that implies nothing but 15 into 12 is 180 plus 15, that is 195 nanoseconds it requires. 195 nanoseconds it requires. So the minimum delay required to get the final output is nothing but 195 nanoseconds. That will be the worst case delay. Okay, actually this is worst case delay. This is the right answer. Thank you.